Okay, finally, let's show how we use this to do problems. So what we're going to be using this for now, we're going to be using it for a lot more later on, is going to be using 3-line charts to sketch. Identify the 3-line chart for f prime of x below and use it to sketch f double prime and f of x. Actually, I should say use it to sketch possible graphs. Especially for f of x, there are going to be many graphs that we could sketch. We just have to do one that could be a possible graph. So let's start out with f prime of x in the middle here, and f prime of x just looks like this. It's actually an x squared function. X squared minus 4 would be this one, in fact. 0 is at -2, 0 is at 2. Let's start off by sketching its 3-line function. So on top, we're going to do concave up, concave down. It's concave up for the entire thing. Next, we've got increasing, decreasing. It's decreasing until x equals 0. And then increasing after that. So that means there is a minimum for f prime of x right there. And then plus minus, -2 and 2, positive here, negative here, positive here. Now, let's go ahead and translate that. So over here we're going to have f of x. If we get out our little card, we see that when f prime is concave, there's no translation. When f prime is increasing, f of x is concave up, concave down. So decreasing, concave down, increasing, concave up. So that means there's an inflection point right there. Positive, negative, and f prime translates into increasing, decreasing in f. So positive translates to increasing, negative to decreasing, positive to increasing. So we've got a maximum and a minimum right there. So let's go ahead and sketch this up here. We know that we're going to have a concave down piece and then a concave up piece, and that matches with this increasing, decreasing, increasing. We don't know if it's all up here or if it's all down here or wherever it is because we don't have a positive negative graph. And yeah, there's no way for us to know it, so just sketch it wherever. But we should definitely have at -2, at 2, and at 0 some special things going on. So we should have increasing until -2, then a maximum, then decreasing, then we should have an inflection point at 0, so now we've got a cup shape, continuing to decrease until 2, and then up again. Something like that. Then we can also do our translation going the other way, f prime to f double prime. Concave up, concave down translates to increasing, decreasing. So it is always increasing. Increasing, decreasing translates to positive and negative. So 0, decreasing is negative, increasing is positive. So that means for f prime of x, we've got some function that's always going up. It's going to be negative on this side of 0, positive on that side of 0. We don't know if it looks like this, like an x cubed, or straight, like a linear function. Generally, as we take the derivative, our function gets flatter and flatter and flatter. So our best guess is probably just a line like that. And if we do our work with our actual derivatives that we know how to do, we can actually confirm this. This I happen to know because I wrote it, is this function. You can tell though that it's some sort of x squared minus something. And that means that when we take the derivative of x squared is 2x, and whatever this is, it doesn't matter, it's going to be 0. So that means this is 2x, it is indeed a linear function, just like we drew it. And over here, if we take the antiderivative of f prime, that gives us f of x. So we add 1 to the exponent, divide by the new exponent. Antiderivative of -4 is -4x. And yes, we have some sort of x cubed sort of little function. Now the key thing here is that this plus c, this is why this plus c is so important. Because the plus c tells us that we have no idea what the positive negative line is. This could be moved up and it'd be correct, it could be moved down and it'd be correct. That's totally fine. Okay, one final check for understanding problem and then we're going to be all done. There's one little trick to this. So you might have one question on how to handle one particular thing, but do all that you can and then come back and look at the video. Identify the 3-line chart for f prime of x below and use it to sketch possible f double prime of x and f of x graphs. So here's f prime of x. It looks like that. Okay, go to it, come back when you're ready. Okay, so here's the thing that's tricky about it. Concave up, concave down? It isn't. It's just some straight lines. We can still do the rest of them like we normally would though. Increasing up to 0, decreasing after that. Oh, so there is a maximum right there. Always negative on that side, negative on that side as well. So let's translate to f of x. No translation. Translates to concavity. So increasing to concave up, decreasing to concave down. There's an inflection point right there. Positive negative translates into increasing, decreasing. It's always negative, so that means decreasing, decreasing. We'll go to sketch it. So we've got something that we've got a cup-shaped piece and we've got a dome-shaped piece. But it's always going down, so we can't do our sort of sinuous function like we did before. We've got to sort of chop it off. Concave down, and before it starts going back up again, that's where we switch. We've got to do the downward side of the dome because we're only allowed to go down. Just like basically if I do it with my hands, here, this cup shape, we can only use kind of this original part. We can't use the part where it's going back up again. Whereas with the dome shape, we can only use, again, this part. We can't use the part that would be going up. So that means, again, we have no idea if this is above or below the x-axis. It really doesn't matter. We're just going to be doing that cup shape up until 0, and then the dome shape after that. Looks something like that. This could be above, wherever. Now let's translate the other way. F double prime of x. So concavity translates into increasing, decreasing. And let's see, this says none. So if we think about what that means, it means there's no increasing and no decreasing. Well, how can that be possible? How can we have something that's neither increasing nor decreasing? Well, the only option is for it to be a flat line. If it's a constant function, then it's okay. Increasing, decreasing translates into positive and negative. Let's see, did I write inflection point? Yes, there's no maximum or minimum here. So over here, we've got decreasing translating to, or increasing, excuse me, translating to positive, decreasing translating to negative, and let's see what we can do here. This is a tricky one to figure out. So if it's a flat line, that means on this side of 0, it's a positive flat line, so somewhere up here. And on this side of 0, it's a negative flat line, something like down there. And what happens at 0? Well, somehow it has to get from positive to negative without being tilted at all. So what that means, the only way that we can do that, it seems really weird to do, is that we basically got this little break here. This over here is a positive flat line, and then at 0 it jumps down to being a negative flat line. And at 0 itself, there is no second derivative. And if we stop and think about it, that actually makes sense, because we know that when we have a sharp turn, a function is not differentiable. We can't take the derivative at this point. So that means that for f double prime, there shouldn't be a value, because there isn't an isn't a derivative of f prime. Also, this makes sense. This is a constant positive slope, constant positive value. Constant negative slope, constant negative value.